Hi, my friend Sam here with another episode of Homebrew Science. Today, I want to dig into the difference between elastic versus webbing for bleeding control. As you may know, I have a product called the Slishman Pressure Wrap. I don't call it a tourniquet, not yet anyways, but I want to know how much of a difference it makes being elastic. Uh, Other things that have triggered this, there's an article, 2016 Journal of Special Operations Medicine, called Significant Pressure Loss Occurs Under Tourniquets Within Minutes of Application. Additionally, there is a doctor, a very well-known doctor named Andrew Fisher, and he has published tons on the topic of tourniquets, and he recently did a live and where he made two statements that got me thinking. One of them was the majority of tourniquets that are applied probably didn't need to be applied. And another one, and I'm paraphrasing, most people who come in with tourniquets applied have palpable pulses. And the question to me is how much of that is because of education, or people who just aren't pulling hard enough, or is it because they're using webbing based tourniquets rather than elastic? Uh, I know I'm very biased here, but I'm just going to let you see the data, the science, and maybe you'll go out and reproduce some of it yourself. All right, I'll show you the experimental design now. All right, here we go. I have 5 pounds hanging, dangling there. And what I'm going to do is have that same weight hanging from a structure up here, for lack of a better word, a structure. And this structure rotates. And what'll happen is that weight will get lifted over a bag of red water and green water. All right, so here we go. This is the tubing, and that is where it goes. And then it goes all the way up to the top, roughly 2 meters up. And I will admit, I've had a hard time getting these little bubbles out, but it doesn't make a big difference when you see what happens. We're going to compare 5 different bits of material. So here's the pressure wrap. This is 2-inch bell stretch. This is 1.5-inch bell stretch, 2-inch webbing, and you already saw the red 1.5-inch webbing. The purpose of these syringes is to, well, it's two different things. It helps me to evacuate bubbles, but once the pressures are up, then I will withdraw 20 cc's, 40 cc's, 60 cc's from each, and we'll see what happens to the pressure drop. I have a red bag and a green bag here. That is to create two different pressure lines that can kind of keep each other honest, because the position is really is very positional. So if I rotate 180 degrees, it's different, as you can see from the height of the two columns over there. So watch that green one shoot up, and then now the red one is going to shoot up. Yeah. So, and I'll take measurements when those two are roughly equal. And the nice thing about two bags is that it approximates the size of an arm or a small leg as well. All right, here we go. We're lifting up 5 pounds, rotating 1, 2 turns there, 3 and 4 turns, 5 pounds up in the air, getting some measurements. And then we lock it in place, take the weight off, and then I go over to the syringes and remove 20 milliliters from each syringe. So 40 milliliters, then 80, then 120. Record it and take it apart, change to 1.5-inch bell stretch, and start to raise that up into the air. By the way, what do you think of that clipboard? That's a custom clipboard I'm writing on there with a magnet inside. All right, so it's going up in the air, almost done. I'm gonna lock it in place, take the weight off, take out 20 from each syringe, so 40, 80, 120, and changing now to 2-inch webbing. Doing the same thing again, lifting up 5 pounds. That was 4 turns. Lock it in place, go take some fluid off, see what those pressures are. And remove that, change it to 2-inch bell stretch. Check some pressures with fluid being removed. And lastly, we've got the pressure wrap, the black pressure wrap. And that shirt hanging out, what can I say? Not pretty. All right. So there we go. All right. And done. Again, okay, here we go with some data, some numbers. Here was phase 1. Once again, I lifted 5 pounds with 5 different materials and wrapped them around 2 liters of water and just measured pressures in centimeters of water. The difference was pretty striking, pretty quick. Elastic is fairly linear. I couldn't do 4 turns because that would have soaked my ceiling. Inelastic starts at the same point, and then even with the second and third turns, there's just resistance between these layers. There's friction, and you don't get a whole lot of pressure gain. You'll notice Velstretch 1.5 did the best, and I was surprised by that. At one point, I wanted to use Velstretch for the Slishman Pressure Wrap, but I opted against it because it had loops only on one side, and it was bulkier. So we'll keep the current material, but this caught my eye. You know, there might be one other conclusion. I don't think that you should use your leather belt or your inelastic surf leash as your improvised tourniquet, but if that's your path, maybe it's better to spiral it than layer one on top of the next. But probably the right thing to do is just buy a Slishman Pressure Wrap and be safe. All right, so phase 2 here, again, what I did was from one syringe, I pulled out 20 milliliters, and then the other syringe pulled out 20 milliliters. So you have 40 milliliter jumps, 40, 80, 120. And I started everything at 140 centimeters of water. I planned this initially to have 50 milliliter jumps, so 50, 100, all the way up to 350. But the difference was so striking so fast that I had to change these numbers a little bit. So with elastic, it's obvious. It just holds the pressure better. With inelastic, even taking out 20 milliliters, I could see the drop quickly. And so this was done to try to understand what's going on with tourniquets. Why is it that arterial pulses come back after they've been on for some length of time? And I think when people assess tourniquets, they're doing it the wrong way. They always put on the left arm, crank, 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 and then check for a radial pulse, and they say, "Oh, that worked." But it's just not real life. What's happening in real life is you have the tourniquet applied, and it's constricting for minutes, perhaps hours, and pushing fluids out of the way. So that's one thing that's leading to less fluid underneath the tourniquet. And then assuming you have actually bleeding too. So that is less fluid in there too, and less pressure. So I think that tourniquets may be stopping arterial flow initially, but it's not surprising to me that under inelastic types of tourniquets, you regain pulses sooner. So the conclusion to me from this is elastic is the way to go. Some people may say, well, the big problem with elastic is if you wrap too many times, then, especially on a small limb, you may create some tissue damage. And that's fair enough. For me, I'm not a psychopath. I am going to apply it only until bleeding has stopped. And then once pain increases with the pressure wrap in particular, I can back it off a little bit too, and monitor closely. So I don't call it a tourniquet, but a true confession, the Slishman Pressure Wrap is my favorite tourniquet. And now I wasn't planning on doing phase 3 here, but I thought a lot of people are going to say, why didn't you just wrap some tourniquets around those bags and see what comes up? And so, if you live long enough, you wind up with 12 different tourniquets in your house. So I did that. It was very hard to get the starting pressures to be the same. I could get between 140 and 165 for all of them. And the reason is, with a lot of these, you pull first, and then you have to do, the windlass, you have no control of that top pressure. The ratchet is a little bit better. With the pressure wrap, you can dial it right in. You get exactly that starting pressure that you want. And you'll notice they all have the same sort of behavior. You take away 40 milliliters and pressures underneath drop quickly. And by the time you're up to 120, the tourniquet becomes just an article of clothing. Elastic it just works better. The only elastic tourniquet that I have is a SWAT T, and so that is the green here. I'm not going to name the other tourniquets because, well, some of them are made by friends of mine, and no hard feelings, but I am highly biased now in favor of elastic for bleeding control. All right. Once again, please try to reproduce these results. And if you like this video, give a like, maybe subscribe. And I will leave you with some outtakes from me trying to do some science with my kids. Not for the faint of heart. Okay, be well and be safe. Bye. Sam here with Max, not Zach. Zach is pooping.
Maybe we should edit that part.
Okay, we'll edit that part. And this relates to bleeding. So very often when you put a tourniquet or a pressure wrap onto somebody who's bleeding.
Oh, so that's what the syringes are for.
That's why the syringes are there. That's
and
right.
also to remove air bubbles.
There's the camera right there.
Hi.
All right, yeah. You just can't stay put, can you?
I can't.
You can't stay put. So what we'll do is remove 100 milliliters, so 50 from each side, 50 from the red, 50 from the green. 50 from the red and the green.
I'll take this very strong because I don't want this to be falling on our feet.
It's very strong. All right, there's some pressure increasing on the red side. Look at that shoot up.
Oh my God.
It was shooting way up on the red side. It's gonna drop down. The green side's about to go up. 7.
What's the, oh yeah.
57 centimeters.
57 for the green?
They're both the same. So I'm
so I'll just grade it for both.
I'm gonna go up here and I'm gonna take 50 milliliters away from both of these. Okay? That doesn't help. Okay? So basically this drops to the level. The pressure has gone away.
Okay.
So we can even say 0. Can you put a 0 on there?
Okay. Wait, like under 100?
Yep. 1 centimeter off the ground. You can't help yourself. Just can't help it. You have a job. You have. All right. The green is. And what's going to be the next strap? All right. I am introducing our other helper, Zach, up high. Call him Zach up high.
Yeah, we're no longer.
What do you think, Zach? 64 or 65? 64.
65.
65, okay. All right, now let's get, what's the next measurement?
Okay, that's, I just saw it,
Right now
I
I
think
can
75.
Right. Or
85.
Or-
No, 90.
I think we're a little closer to 57, maybe 58. 58
It was
Vanessa?
75. 100. Okay,
Guys, look down
57.
there.
91.
91.
Actually, maybe 91 and a
91,
half.
Vanessa.
91 and a half.
No, 92.5.
92. We're doing 92.
91 and a half. 91 plus a millimeter. Okay.
Let's
91
go to
plus
100.
91
We're
plus
at 100.
Interesting already.
Which one was it when it leaked out the cup?
78.
78.
Yeah, for turn. turn number 3.
70.
Yeah. And I'm going to get a 4th turn in too, because I can.
Pass you the clippers. If you want the clippers.
Oh my god!
Well, I don't need the clippers because I'm right here. So I appreciate that. So now I'm going to withdraw.
That's why you never use the Home Depot tourniquet.
That's right. Take it
I
down
can't
to
believe
50.
Home Depot actually sells tourniquets.
Oh, no, I call it a Home Depot tourniquet, but it's not really. Now look at that. The pressure dropped to
Like
6 cent. Basically,
this has the
it
worst.
has no value. So if I remove 100 cc's or 100 milliliters of fluid from these bags, the pressure drops. What's he doing?
I'm aiming right at that.
Here's those 50 milliliters.
Guys, look at mommy's detective coat.
Oh my goodness. All right, you want to press pause, love? That's fine.